Hi, this is a quick one. My name is Dan. I'll be taking you through Laplace transform of a function f of t equal to 4. I have done an introduction to this video. Locate introduction to Laplace transform in this playlist. Under that one, I discuss Laplace transform for a function f of t equal to a, where a is a scalar. So I'm taking an example in this video for that one. You can locate that video. It's very important that you watch that video before you attempt this one. This is an example to that question. So wait, please subscribe to this work. Don't do that, just please subscribe to this work. Click on the notification button for more updates. All right, so let's see what we have today. So we learned that the Laplace transform of a function f of t is given by, alright, so we have f of t equal to 4. So we substitute that. So we have Laplace transform of 4 giving us integral 0 to infinity 4 times e minus st dt. Alright, so the next step is to integrate this function. I am not going to take limits. I'll just introduce the upper and lower limit into the function to make it quick. Alright, so from here, we integrate the function. I can factorize the 4 out, giving me 4 integral of 0 to infinity. We have e minus st dt. Alright, to make it very simple. Now from here we integrate e to the power negative st. Now let me show you how to integrate a function like that if this is the first time you are seeing my videos. So we have an exponential function, let's say e to the power at or ax, whatever variable you want to use here. This is the coefficient of this. Let's assume this is a scalar. Then the integral of this function is the same as 1 over a e to the power at, or you can also say e to the power at all over a. Remember that this is a fraction, this is over 1. A times 1 will give me a. 1 times e to at will give me the same result. Alright, so if I have something like e to the power negative at, then the integral of that is going to give me 1 over minus a e to the power minus at. Okay, when I substitute a scalar for this one, the result will change. So if I put 2 here, then this side will be what? 1 over negative 2. In this case, we have negative s. So the result remains the same. So we have e to the power minus st. So the integral of this is giving us 1 over negative s e to the power minus st. Very simple. Okay, all right, so let's move on. So I'll just integrate this side and introduce my upper and lower limits. So this is giving me 4 times 1 over negative s e to the power minus st. Then I will introduce my limit, put this into brackets, 0 to infinity. Dt is gone because I've integrated the function. Now, this becomes simple for us to solve. We have 4 times 1, this is over 1. We are having 4 over s. Don't forget we have a negative here, so this is negative 4 over s times our e minus st to 0 infinity. Remember that t is from 0 to infinity, so this is t, this is t. Alright, so for lower and upper limit, we take the upper limit minus the lower limit. So from here we have minus 4 over s times, then we substitute our upper limit, e minus s into infinity. You close your bracket, minus, you take another bracket, e minus s into 0. Okay, so this is my lower, this is my upper. Now remember that as t approaches infinity, the result converges to 0. Okay, if you really want further analysis, if I have a function where we have the limit of what? E to the power negative x, or let me use t. Okay, negative t. Okay, so then when t approaches infinity, this result is equal to 0. That was what I was trying to explain here. Okay, so everything we have here is 0. Everything we have here is 1. If I raise a variable like t to the power 0, the result is 1. So if I have e to the power, let's say negative 0 or positive 0, the result is 1. Okay, so we have negative 4 over s multiplying this side is 0 minus 1. The whole result here is 1, so minus 1. Now all you need to do, use this to multiply that. So we have negative 4 over s times 0, the result is 0. We don't need that, so this time this, the result is 4 over what? S. Alright, so all we are saying is that the Laplace transform of the value 4, the scalar 4, is giving us 4 over s. So if you watch my introduction video, I gave this example there, but I wanted to solve it for you to see. So this is the end of this one. Please subscribe again to this channel if you haven't. My name is Dan, and I'll see you in the next one.